Welcome to Ask and Learn.
Okay, now we are being asked to show that the equation has exactly one root, and the equation is x cubed plus e of x equals 0. And we're trying to prove that this function, that there's only one value that gives us x cubed plus e of x equals 0. And so there are many different ways to prove this, and one way to prove I'm going to use involves limit. So if we take the limit as x goes to negative infinity of x cubed plus e of x, what happens? So what actually happens is we get a really, really big negative infinity number, because as x cubed grow, it was just the negative 100 cubed that is still negative, so it'll give us an even bigger negative infinity number. So we're going to label that as negative infinity, and then we're going to get plus e to the negative infinity. Now recall that this is an exponent, so any number raised to a negative exponent means you put it under the denominator. So e to the negative infinity become 1 over e to the infinity, and 1 over a very large number approaches 0. So this approaches negative infinity. Now the limit as x goes to positive infinity of x cubed plus e to the x is just simply infinity plus infinity. And infinity plus infinity is still infinity. It's still a very large number. So now you can see something very interesting happening. So when the number is very, 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 very negative, it's negative infinity. And if one is very, very, very positive, it's positive infinity. So that means that there is a point such that between negative infinity and infinity, that this function has to cross the x-axis. So there has to be a point where this is equal to 0. And this is true because we know this by the intermediate value theorem. And we know this because this function, x cubed plus e of x, is a continuous function. X cubed, as a cubic function, is continuous, and e to the x is an exponent function, which is also continuous on all real numbers. So by the intermediate value theorem, we know for a fact that there is one root, but that we know that there is at least a root, not necessarily one root. To prove that there's only one root, we have to take the derivative of x cubed plus e to the x. And the reason why is this tells us a lot about how the function is behaving. And so 3x squared plus e to the x, because that's the derivative. And this derivative is always greater than 0. It's always increasing, because x squared, even if you put a negative number, it is always positive. And so since this function is always positive, we know that it's always increasing. It never decreases. It always rises. It always goes up. And so when this is at negative infinity, we know that this has to cross the x-axis once, because it's always going to be increasing. And so that proves that there's only one root. So by taking the derivative, we prove that there's only one root, because this function is always increasing on all domains. And so that proves it. So in general, when you're trying to prove whether the equation has one root, you're generally probably going to use the intermediate value at some point to prove that there is even a root. So that's a good way. That's a good starting point. And then when you want to prove that there's only one root, there is a variety of ways, but you can take a very easy way to check is to take the derivative and then see how that function is increasing or decreasing on its interval. And that can tell you a lot about its behavior, and that can tell you about whether there's one root, two root, or give you some sort of sense of idea of how many roots they are. So in this case, we know that there is only one root because the function is always increasing, and we know that there is a root due to the intermediate value theorem.